Hello again, everyone. This is Josh Morales from Falafel Software, and thank you for joining me for another video in the series on the HoloLens and Unity Playground. Today we are once again looking at Unity, and we're doing things a little bit differently this time, whereas in the previous videos we've been focusing on the HoloLens, both with the Hello World project in Visual Studio as well as the Hello World Style project in Unity. This time we're doing things a little bit differently because I actually discovered this TechRewards code challenge on building apps for Unity. And if you're not familiar with TechRewards, this is a program that allows you to earn points for completing code challenges as well as for creating and submitting apps to the Windows Store. If you are not a member, I definitely encourage you to visit rewards.msdn.microsoft.com to sign up, learn more about the program, and become a member and start earning points. It's a great way to earn while you learn and become part of the community while earning some points for some fantastic rewards. In this case, this code challenge here outlines a lot of steps that we'll be going through today. And essentially, I just want to go through them together and see if we can complete the challenge, tweet a screenshot of our program, earn some points, and learn together this challenge and see what it has to offer. So if you want to follow along, again, that's rewards.msdn.microsoft.com. Sign up for an account and get started. Remember, all of the tooling for this is free, both for Unity and the Visual Studio Community Edition. So there's no reason to sign up today to get started. So let's go ahead and kick this off. The first thing that we want to do here is create a new project. And in this case, before I proceed, I do want to make it clear that I am not using the HoloLens preview, as we are not creating a HoloLens project. That's not the intent of the challenge. It's really more of a getting started in Unity. But given that HoloLens is tied so closely to Unity, I thought it would be a good opportunity for us to get a little more familiar with getting started, the environment, and all that. So if you're looking for more practice in the Unity program, this is definitely a great opportunity for you to explore. So that being said, we're on Unity 5.3.4 F1. So we'll get started here by creating a new project. And we want to make sure that we are selecting the 3D view. And the challenge does also ask us to open up the asset packages and see the different options that we have available to us. In this case, the challenge wants us only to include the Visual Studio 2015 tools, which will enable that development synchronization here. So we'll go ahead and select that and hit done. We've got the 3D project, and we'll go ahead and call this TechRewards Challenge. Hit enter and fire that off. And we end up with the default environment for a Unity project with both a default camera and a directional light. Now, at this point, the challenge goes on to describe a lot of the IDE, which is definitely covered in there, so I encourage you to take a look. The next actual step that we need to do in this challenge is to create a game object. So we'll do that from this menu here, and specifically, we need to create a 3D object, which is, in this case, a cube. And we want to rename this cube by clicking twice. That's not double-clicking, because I made the mistake of double-clicking, which zooms in on the project. To rename, you want to click twice slowly so that it enables the rename. And we're going to call that enemy and hit enter to save the changes. We then want to create another 3D object, also a cube, and we're going to call this one the player. So I think I can see where they're going with this already. And next, we want to tag this game object that represents the player in the inspector with a player tag, which is actually appears to already be built in. So we'll go ahead and select that option here. And our next step from the challenge is in the scene view here, which I'll zoom out a little bit. Both the player and the enemy are stacked upon each other, and we don't want that. So we want to go ahead and move the player object away from the enemy objects in the x-axis, which is represented by the red axis here. So I'll go ahead and switch to that mode, and I can now pull in the x-axis to pull the player away from the enemy object. Great. And the next step is that we want to give the enemy cube some logic. And so we can right-click in the project window, and we'll create a C# script. And it asks us to call this enemy AI. So we'll go ahead and click that. And we want to associate this script with our enemy object. So we do that by dragging our script onto the enemy object, which if we select that in the inspector, now reveals that we have the script associated with that game object. So that's great. So next thing we want to do is go ahead and save our work. Go ahead and call this scene. We'll give it a name. We'll just call it first scene. And now we want to take a look. The next task here is called Introduction to the Visual Studio Tools for Unity, and starts us off by double-clicking the CS script to open up Visual Studio. There we go. So by default, we always get the start and update methods by default. And the challenge gives us some code that we want to go ahead and replace the default script with. So I'll go ahead and paste the code from that challenge here and save it. And then we'll kind of walk through and see if we can figure out what's going on here. So here we have the enemy AI script inheriting obviously from mono behavior, which is a requirement for any script that we want to attach to a game object. And the members of that enemy AI class include speed, which I'm assuming is going to control the speed of the associated object, as well as a transform, which labeled print player probably represents the player cube, and my transform I think is obviously going to represent the enemy AI. In the start script, which we replaced, we are getting an instance of the game object with the tag, in this case player, which was available in that dropdown to get that object here. And if obviously we don't find that because we've neglected to tag it, or for whatever other reason, we definitely want to report an error. Otherwise, we'll go ahead and grab an instance of that transform, which we're going to save here. And oh, it looks like I did not copy the full script, so let me go ahead and do that. Sorry. Copy the rest of this. Actually, let me just go ahead and copy the whole thing again. And I will replace this here. Paste. There we go. That looks a lot better. So we're getting a copy of the player's transform and storing that away, as well as the transform of the current enemy object. So in every frame now, we want to, and oh, I didn't see these comments. So setting how fast I should move toward the player. So it looks like the enemy object is going to be moving towards the player. It gives in Unity 1 unit is a meter. Oh, okay, that's good to know. I had seen that in Unity that objects had kind of a 1 by 1 by 1 spatial definition, for lack of a better term, but I was not aware that specifically it represented a meter. I don't know if that's what it says in Unity, so that's good to know, definitely. Delta time, the amount of time since the last frame. So there's some math here that's probably really good to get familiar with. And in this case, what we want to do is the amount of movement is going to be the speed, which is a variable of the enemy AI script, times the delta time. So we want to update the position by moving the AI cube towards the player position by using a vector 3 move towards, and we're going to use that transform of the position of the, it looks like this is what the current position, which is where the cube is, and then the target position, which is where the player is, and then the movement amount, which appears to be, okay, it says max distance delta, which is straight line towards the target point. Interesting. Seems to be related to the speed at which we define. So I'm guessing moved from here to there at this speed. Makes sense. And then here it says if we hit the position of the player, then we want to go ahead and bounce backwards by 10. So looks like we're going to be hitting the player, and then I guess when we slam into it, maybe we kind of do a bump cars thing. I'm not sure. I guess we'll see how that works. So now that we got that code in there, we want to go ahead and save our changes to the enemy script. And now it kind of wants to go over debugging, which makes sense here in an introductory challenge by setting a breakpoint in the start method, I guess just to prove that this works. And drop down control to the right of the green play button and select attach to Unity and play, which is interesting because every sample that I've seen up until now has done launching a Visual Studio from the build settings. So in this case, we're launching by attaching to Unity directly, which makes sense. I just hadn't seen that before. So looks like the next step is to hit play. So let's go ahead and do that and see what happens. Okay, so there's some notes here. It says if the breakpoint isn't hit within 10 seconds to switch to Unity and click the play button. So I guess I'll give that a second to fire up. Let me see if there's anything in the output window. Doesn't seem to be any movement there. So I'll go ahead and come in here and hit play. And then it says you'll need to hit the play button again to force it to stop when you stop debugging. Okay. So if the attachment doesn't happen for whatever reason, come over here and fire it up in Unity by hitting play. In this case, it looks like we got it to hit our breakpoint, so that's great. We obviously want to find the game object with that player of tag, and that should give us here an instance of that player game object, which is the cube. Okay, that makes sense so far. We do have an instance, and we'll go ahead and store the transform of the player and the transform of the enemy cube. Excellent. Looks like we also have some locals that are auto-populated with pretty much the same variables, as well as some autos, just basically revealing the fact that Visual Studio definitely supports full debugging experience, which is good to know. So the next step we have is, this is obviously going to exit, so we want to set a breakpoint in the update method, which gets called once per frame. So we'll go ahead and step out of this method, and now we're kicking off the update frame and getting the move amount, which is this variable here with a one float value, sorry, and we're going to move towards the position of the player, or rather the cube, which is actually at origin. That makes sense, 0, 0, 0, towards the player, which is at a position in the x-axis, totally making sense with what we had. And we're going to move that direction, and until we get there, we'll just skip that and then continue to move towards it. So if I go ahead and undo this breakpoint and continue, we can hop back to Unity and see, looks like the cube is hitting the player and then resetting, which actually makes sense, as now that I look at this, that the transformation position, if it's equivalent to the user's position, that we want to set the position equal to the vector backwards times 10. So that makes sense. It is instantly setting that position. So the fact that it's kind of bombarding the player over and over makes sense given that consequence. So that makes sense. We'll go ahead and, it says that we can, by setting a breakpoint here, this is kind of interesting, we can actually manipulate the property of the speed variable by changing it to, say, 10. Oops, 10, not 10F. There we go, and it's at 10F. So now if we play it, let's see if we actually get a reduced speed. Yep, look at that. So now it's moving at what, 1/5 of the speed, and that is exactly what we expect. So that totally makes sense. Essentially, I guess this is just proving that the debugger is fully featured, and that's really good to know. Walks us through opening up the documentation, which I'm not going to go through because the documentation is pretty accessible in Unity, and both within Visual Studio, within Unity, and then also on the Unity website. So we'll move on to, looks like what's called the Mono Behavior Wizard. And it says, lets you visual pick the Unity method by hitting in Visual Studio Control-Shift-M. And oh, this is neat. So this is really cool. So actually, it looks like this is a list of all of the methods that are available to the monobehavior object. So I know that there's a lot of methods that you can apply to your class, such as specifically the ones that I'm familiar with are on trigger enter and on collision enter. So rather than trying to remember or memorize all of these um, methods, it looks like by using this shortcut, you can kind of pick and choose with a point and click interface. It's really handy. I was not aware of that. That's very cool to know. So here it tells us to select the on mouse up event. So we'll check that and hit OK. And sure enough, there's our method. And this is actually cool. So again, that was Control-Shift-M. This is kind of cool because if you look here, it not only will memorize, or rather present the full list of methods that you can select from, but it also will fully implement the signature of that method. So if I select, well, I don't want to say 2D, so if I do on collision enter, in this case a collision, it's actually going to present that, it's going to present that signature so that I really don't have to memorize every possible method available to the model behavior object. So that's really cool. Wow, these challenges are definitely worth more than just throwing you in the environment. That's definitely a lot of things to learn here. So it looks like, okay, there's a quicker way to implement the individual behaviors if you know what you're looking for by using the shortcut Control-Shift-Q. Oh, and okay, this is cool. This looks like it's a fill in the blank. So 65 available, 2 already. So it's telling me I already got 2 already. So if I know what I'm looking for, so I want on collision, but I don't remember the. So if I don't remember necessarily the exact signature, I can select it from here and I kind of fill in the blank. So that's really cool. So that's Control-Shift-M to bring the list of methods, and then Control-Shift-Q to do kind of an auto-complete. Very handy. That is really cool. So the next task here is refactoring the code, and this is interesting. So usually every sample that I've looked at has this kind of in Unity and then kind of go into Visual Studio to verify our work or maybe modify the script, but everything gets created in Unity by, in this case, right-click create script or whatever it is we're doing. But this one actually tells us to go to right-click the assets folder in Visual Studio in the solutions folder and add a new item, and we want to select a class. And for some reason, I happen to have 2 classes. I don't know what that's all about, but for whatever reason, we'll go ahead and add a new one and call it enemy movement as specified. Movement as specified by the challenge. And also, once again, we have a script to copy and paste. So I'll go ahead and replace this one here. And it looks like we have some usings to populate control period, which is the best shortcut in Visual Studio. I will fill that in. And all right, so it looks like at first glance that this is absolutely a refactoring of our previous code, whereas in this script, we were doing the transform in the AI script, storing that instance here. It looks like we're wrapping that into this kind of container class that is going to store those, transform the speeds, and move towards target. So that makes a lot of sense. So now we can kind of abstract that behavior into a separate script. Okay, so I see where they're going here. Next, we need to modify the enemy AI class. Let's say this enemy AI class, and they do give us, again, some snippets here. It looks like what they're doing is commenting out the existing code, but I'll go ahead and just copy and paste it because that's what is provided. So yes, it does indeed comment these out, and we want to add a reference to the enemy movement that we just defined by including the assets here, the assets namespace rather that was generated. And then we want to replace the start method, which is now a little bit simplified because all of that initialization and storage of the properties is now a job of the enemy movement class. So we initialize it with a certain speed, with a certain transform of the enemy AI object, as well as the player transform. So that gets contained in this enemy movement object. Okay, makes sense. And then the update method looks like it's really simplified because the only thing we need to do here is offload all of the processing of the movement to that external class. So that is definitely a much cleaner definition of this behavior. So if we save this, let me pop back into Unity, and sure enough, there's our enemy movement object. Totally makes sense. And since it's defined through the player script here, the enemy script here, it is actually a member of that script, so we don't actually have to consistent line endings. Oh, that's fine. We'll ignore that for now. Save all. So now if we come back to Unity, if we hit play, we should get pretty much the same behavior that we experienced before. And sure enough, there it goes, zapping right over, zap, 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 zap. Very cool. So that's pretty much the end of the challenge. It looks like we want to grab a screenshot of this, so I will go ahead and pull out the game tab. Oh, pull that. Oh, there we go. I want it floating. I'm going to hit play and get a nice screen grab of our player. Just grab a split screen there, and we'll go ahead and tweet that out. And that should complete this challenge. Now, I'm very interested to see what will happen if we take this project as it is and simply build it and fire it up in the HoloLens emulator. I don't know if it will get the 3D effect, or if it'll show up as a 2D, a 2D XAML project. I have no idea. But I'm going to go ahead and end this here, and we'll record a new video. I will build this, launch it in the emulator, and then actually, given that this is the non-HoloLens version of it, I'm actually very curious to see what will happen. And then whether or not it works, we'll go ahead and open this same project in the HoloLens preview version of Unity and see if we get any different results. So if you're interested in that, stay tuned. We'll have another video coming where we explore that just to kind of see what happens. So until then, I definitely reached the end of the challenge, so I hope you'll do the same. It looks like the challenge ends in 12 days, April 26, 2016. So if you're watching this video now and it is before that date, head over to rewards.msdn.microsoft.com, sign up an account, and do the challenge for yourself. Join me and tweet out your screenshots and let me know how you fared. And as always, I hope this video was helpful, and we'll see you on the next one. Thanks for joining. Goodbye.